Thank you for taking your time to see my session. So I'm Katsuhiko Kageyama. So today I'd like to talk about creating your own computer. My first question is, what's your childhood dream? I had a dream. So it's playing video games freely. I also had a dream to create video games by myself. In order to make video game, we need a tool. For example, this was Family Basic. This is can be used with Family Computer, a Nintendo Entertainment System. So we can make a small game using this hardware and software, a cassette software. Today, so we are not child. I considered to make a video game hardware by myself. Today, in this session, I want to tell you, you can make your own computer with mruby. So, let me make my introduction. So, I'm Katsuhiko Kageyama. I'm an embedded software engineer in a manufacturing company. So I'm making some mruby devices as a hobby. Also, I'm making technical books. Let me show some my devices. So you can see some pictures. So I made a small computer using Raspberry Pi Zero. Also, I made a small game using a microprocessor. So this is my activity. So let me show my today's agenda. So first, how to create your computer. I'd like to explain it. Then I will show why I choose the mruby. Finally, I will explain important technical things about mruby. Also, I will show some demonstrations. Goal of my development I want to show. So my goal is creating my small computer to run Ruby script like Family Basic, as I mentioned. So I want to call it Family mruby because I will use mruby. Also, I made a long mark. I think it's fun. So I want to show how to create your computer. There are some steps. So first step, define requirements. And second step, find components to make the devices. Also, you need to make schematics. Based on the schematics, we will do manufacturing for the device. After that, we need to implement software. we need to take these steps. Okay, let me tell you more about each steps. So first, define requirements. This is comes from your idea. So let's define requirements as you want. Second step is find components. So today there is some good worldwide software to find components. So I'm using this key for finding components. After that, make a schematics. So this is might be difficult for software engineer, but I think it is not so difficult to make a digital signal schematics. So we can use the CAD. This is a CAD tool for making schematics. This is provided with a charge. So after making the schematics, we can go to next step to manufacture the devices. For example, a Chinese company offers the very good prices for manufacturing the hardware. For example, $5 for five boards. I think it's very cheap, but the quality is enough to use it. After that, finally, we can implement software on the hardware. Without software, your hardware doesn't work. In final step, we write application using Ruby. So why I use Ruby? So I love Ruby. Also, no one likes to wait for compiling C source code and flashing images to the device. It takes time. Also, Ruby code is shorter. Shorter code is nice for the small devices. As I mentioned, I use mruby. Why I use mruby? mruby can run on some small processors with limited memory. In general, mruby requires more than 400 kilobytes RAM. Also, simple implementation of the mruby Apache machine. This helps to port it to your own hardware. Then next, let's find the good processor for running mruby. I put a table to show some major processors. So I think you may know Arduino. This is a famous microprocessor for makers. As you can see, the ROM size is 32 kilobytes. So RAM size is just 2 kilobytes. It's very, very small. Also, you can see ESP32. I put two types in the table. ESP32 and ROM 32. It has 520 kilobytes RAM. It's quite big, but it's not enough for mruby. So now I found that ESP32 double robot B. It has 8 megabytes RAM. I think it's good for the mruby. For example, you can see that Raspberry Pi Zero. This has external RAM, 500 megabytes. It's very big, but I think it is similar to personal computer. So I decided to use ESP32W-B. You can see my figures to show the requirements. Yeah, it's a very nice picture. Based on this picture, I made schematics. So it's very small to see what is described in the picture, but I think this is not complicated. Based on this schematics, I could make a PCB board. Also, it was manufactured by Chinese company. Okay, so now it's ready to use the hardware, but we need to implement basic software at first. So ESP32, it's a very small processor. So this doesn't support a rich OS like Linux, Windows. For these processors, the C++ are a common language. We need to use it. That's why it is difficult to avoid C or C++, because low layer library is provided by C or C++ usually, unfortunately. Based on this situation, I made the system diagram. As you can see, this is my device based on the W-B. ESP32 provide Arduino core. I put the FabGL, which is provided by other open source. It can support VGA monitor, also audio output, and PS2 keyboard. It's a very nice library. Then I make the mruby gem, mruby compile and Apache machine. Then user can put their script on this system. For development phase, I use development PC. We can make the firmware using the ESP development tool. Compiles firmware, then transfer the software using serial communication. Once the software is written in the device, then we don't need to connect the host PC. Let me show my hardware. So this is manufactured by a Chinese company. Also, I prepared the black case using the 3D printer. Also, I prepared an acrylic cover at top of the case. Let me explain the difficulty of the software implementation. As I explained, the small processor has limited memory. So we need to take care of the remaining memory always. So also, user need to take care of the memory because the Ruby can make so many Ruby objects on the random memory. So next point is low performance. So because this hardware clock is lower than 1 gigahertz, so its hardware performance is limited. To maximize the performance, we need to consider to use hardware function. ESP32 supports interruption, direct memory access, and so on. This is important to consider to use it. So I want to focus on the interruption. I'd like to explain the hardware interruption. So, for example, the CPU has the interruption function. If the button is connected to the CPU in using the circuit line, if somebody press the button, then electrical signal is sent to the CPU. If when CPU receives the signal, then the CPU change the programming counter from main running program to the interruption handler. This is done by CPU automatically. This is user don't need to consider the switch. Also, it's very fast. For mruby, unfortunately, mruby cannot handle the hardware interruption because the virtual machine resource cannot be accessed from the interruption handler, since the handler has a high priority than mruby. So if we want to implement a similar functionality, we use the polling method like this source code. You can see the input API to check the key is pressed up or down. Need to check in this loop. This is not best way to check the key input. It wastes the CPU performance. So using this software layer interruption, user can add the interruption script using Ruby. This code is called from this entry point function. This is just experimental implementation, so I need to investigate more about my implementation to have more confidence of my implementation. Let's show my Family mruby. This is console screen. So finding the Ruby file, load file, so we can edit the Ruby source code. So this is a kind of RPG game sample. Character can be moved using the gamepad. Okay, I'm using this USB pad. So I'm connecting the pad using the Arduino interface. Okay, so let's move to the next demo. This is a Tetris. Okay, load Tetris source code. Execute. So this is implemented by mruby on the family mruby. So we can play the Tetris using the pad. Okay, let's delete one line. Okay, it works. Okay, let me show the summary of my session. So in my session, I want to say we can create our own device, which is nice. Also, I have created a family mruby. This support happy Ruby programming without any PC. Also, I propose a software interruption method. So I want to make more device. Also, I want to update my firmware based on this family mruby. So I hope you can understand how to enjoy your maker life. So see you next time. Bye.